In this video, we're gonna talk about definition of limits and specifically about graphical interpretation. So what is the meaning of limit as x approaches 1 of a function using the graph? Now, to find the limit, I cannot look only at one part of the graph. So as x approaches 1, they didn't mention approaches 1 from the right or approaches 1 from the left. So I need to consider both cases. The first step, I look as x approaches 1 from the right side. It means the graph, it's taking these points. So if I'm approaching from the right side with x, it means the points on top are approaching which point? Are approaching this point, right? When I say the points are approaching this point, it means as x approaches 1 from the right, our function f of x is approaching the y value, which is 3 in this case. So always the answer of the limit, basically it's gonna be a y value. From where I get it? From the graph. So as x approaches 1 from the right, I can see that the points are going towards the point that has a y value equals to 3. Is this enough? No. We need to look at the left side. As x approaches 1 from the left side, like this, it means like you're starting with this point, then this point, then this point, then this point, and so on. And I can see that I'm approaching the same point here in this case, which has the same y value as 3. Now, as you can see, as x approaches 1 from the right and from the left, I can see that the function from both sides, it's approaching the same point that has a y value equals to 3. So in this case, I say the limit as x approaches 1 of the function is equal to 3. Now, let's look at this question. You're given a piecewise function. This is called piecewise function because it has two pieces. The first piece, the second piece. So that's why we call it piecewise function. Alright. Usually when they ask about limit in this question, they ask you about the value you see there. They can ask about different one, but usually they ask about this. So what's happening when x equals to 2? Is there a limit? Let's check. As you can notice, f of 2 in this question, when x is equal to 2, I know that the y value is equal to 4. Exactly. It's defined by this point. However, if they ask you what is limit as x approaches 2, so limit as x approaches 2 of the function, it doesn't mean that it should be equal to f of 2. So these no need to be equal. Okay? So limit as x approaches 2 of the function f of x, it doesn't need to be equal to f of 2. So using the graph, let's see how much is it. Now, as x approaches 2, I check from the right side and from the left side. Now, if you can do this quickly now, as x approaches 2 from the right side, as if I'm taking these points and I'm approaching this hole. And this hole has a value, or y value, equals to 3. Now, I check from the other side. As x approaches 2 from the left side, what's happening? As if I'm taking these points and I'm approaching again the same hole, which has a y value equals to 3. Now, since when I was approaching 2 from the right and from the left side, my function, the graph, we see, in both ways it's approaching the hole that has a y value equals to 3. Even though we don't have that point, which is the hole, just I'm checking, I'm approaching which y value? It's the y value of the hole, which is equal to 3 in this case. So the limit, it doesn't need to be equal to the f of 2 in this case, which is 4. Just I check it from the graph, checking the points on the graph are approaching which y value, and this will be my limit. 3. Let's say you have this function given as y equals -1 over x, and the question, check limit as x approaches 0 of -1 over x, which is the function basically. How much is that? Again, same idea. I'll just go to the 0 and I think about it. As x approaches 0 from the right side, I look at the curve. What's happening to the curve? It's getting smaller and smaller and smaller. It's getting more down and down and down. It's not approaching a specific number. So the y values of the function are not approaching a specific value. So when I take a very close number to 0, I can see that the y value is gonna be a very small number. When I say very small number, it might be -1 billion, because in negative numbers, if I say -1 billion, it's a very small number. If you want to try, you can try, for example, 0.0001 instead of x, and check the y value here is gonna be -1 over 0.0001, which is -10 exponent -4. Now, if you try x equals 0.000001 and you try what is the y value, it's gonna be -1 over that number, and it's gonna be -10 exponent -6. So as I'm approaching 0 from the right side, I see that the y values are not approaching a specific number. They're getting smaller and smaller and smaller. So in this case, we say the limit does not exist because it's not approaching a specific number. Is it the same from the other side? Yes. As x approaches 0 from the left side, and we take values of 0 or values really close to 0 from the left side, like smaller to 0, like -0.1, -0.001, and so on, we're gonna notice that the function is getting bigger and bigger and bigger and bigger and bigger. It will take very huge numbers. So it's not basically approaching a specific value of y. In this case, we say the limit does not exist. DNE, it means does not exist. Alright, let's check number 4. If I ask you about limit as x approaches 2 of the function f of x. So in this case, I guess it's easier now. We go check as x approaches 2 from the right side. I can see that the function, by taking these points, are approaching this point that has a y value 1. So as I'm approaching from the left side, I see that the function is approaching this point that has a y value 1. But when I'm approaching from the right side, I can see that the function, so by taking these points, are approaching the whole that has a y value that is equal to 2. Now, since the function is approaching 2 different values as x approaches 2, so when I check as x approaches 2 from the right, the y values are going to 2. When I check as x approaches 2 from the left side, I can see that the points are going towards the point that has a y value equals to 1. Now, since these two numbers are not equal, also in this case we say the limit does not exist. So the limit exists whenever I'm approaching an x value from the right and left side, and the function is approaching the same y value. Number 5. If I ask you about limit as x approaches 1 of the function f of x, how much is this? Again, I need to check when I'm approaching x from the left side. I can see that the points on the graph are approaching the whole that has a y value that is -1. Now, as x approaches 1 from the right side, I can see that the points on the curve are approaching this point that has a y value equals to 2. So as x approaches 1 in general, when I'm approaching 1 from left or approaching 1 from right, I'm getting two different values, which are -1 and 2 for the y value. So when you get two different numbers, in this case you say the limit does not exist. Now in my next video I'm gonna explain more details, and we're gonna call these limits as one-sided limit. We're gonna talk about the rules of limits or properties of limits and how we can calculate limits.